This is Meyer Werft shipyard. They are constructing the giant cruise ship Quantum of the Seas, which is one of the largest and most advanced cruise ships in the world, offering a wide range of amenities and activities for passengers. This is the first cruise ship of the Quantum Ultra class with a total capacity of 169,000 registered tons, BRZ, 347.1 meters long, 41.4 meters wide and accommodating 4,246 passengers. It has 16 passenger decks and is operated by a crew of more than 1,500 members. Meyer Werft's Quantum of the Seas construction process. 1. 3D Virtual Reality Laboratory of Quantum of the Seas. This is an internal tool used by ship designers and engineers during the planning and construction stages to visualize and optimize ship layout and features. 2. Laser Hall of Quantum of the Seas. During this stage, cranes will move giant metal sheets into position for processing by using lasers to cut them into parts according to existing design drawings. This process involves computer-aided rendering, CAD, of the object to be cut. Laser cutting machines are calibrated to the specific material and thickness being cut. This calibration includes adjusting the power, intensity, and focus of the laser beam. Laser cutting offers high precision, minimal material waste, and the ability to cut complex shapes and patterns. Three. The assembly of large ships Quantum of the Seas generally involves a process where the ship is built in sections, known as blocks. These blocks are constructed individually and then assembled together to form the complete ship. The ship's hull and superstructure are divided into blocks. Each block is prefabricated, often with pre-installed components and systems. Within each block, various systems and components are installed, including engines, cabins, plumbing, electrical systems. The assembly of large ships Quantum of the Seas generally involves a process where the ship is built in sections, known as blocks. These blocks are constructed individually and then assembled together to form the complete ship. The ship's hull and superstructure are divided into blocks. Each block is prefabricated, often with pre-installed components and systems. Within each block, various systems and components are installed, including engines, cabins, plumbing, electrical systems, and more. After construction and inspection, the blocks are transported to the dry dock or assembly area using heavy equipment like cranes or specialized transporters. Here, giant cranes will lift these blocks into the designated position. In it, the blocks, each weighing thousands of tons, found their rightful place in the grand design of the ship. Precision is key. The alignment of every block must be perfect, ensuring seamless integration of the ship's components. The assembly process is more than just mechanical. It requires human skills and advanced engineering. Each block must bond perfectly with its corresponding blocks, creating a cohesive structure that can withstand the ocean's immense power. Welders, engineers, and technicians work in harmony, converging expertise to create a unified whole. And more. After construction and inspection, the blocks are transported to the dry dock or assembly area using heavy equipment like cranes or specialized transporters. The blocks are lifted and carefully positioned using cranes, and then they are welded or otherwise attached to each other to form the complete structure of the ship. Four. Cabin factory and cabin installation. Once the blocks are assembled, the ship begins to take its final shape. However, this is not the end of the journey. The Quantum of the Seas, now looking like a majestic ship, is entering its outfitting phase. This stage is like breathing personality into the steel veins of the ship. The lavish cabins are meticulously furnished, with interiors that exude luxury and comfort. Public spaces come to life through installations of artwork, lighting fixtures, and intricate decorative elements. Restaurants, theaters, and entertainment venues are filled with an atmosphere that reflects the epitome of luxury. At the same time, countless systems are seamlessly integrated into the ship's structure. Advanced navigation systems, safety protocols, and precisely calibrated communication networks. The heart of the ship, its engine room, became a marvel of engineering, where the massive engines and propulsion systems were fine-tuned to perfection. It is a testament to human ingenuity. Every corner of the ship is optimized to deliver efficiency, safety, and a great experience for guests. Five. Quantum of the Sea's departure from building hall. Preparations for Quantum of the Sea's departure begin with a comprehensive inspection. Every inch of the ship is scrutinized, ensuring it meets strict standards of quality, safety, and excellence. Engineers and technicians meticulously examine the ship's systems, from the propulsion engines to the complex network of electrical wires. Safety procedures are reviewed and emergency systems are tested to perfection. It was the final, meticulous assessment, the last-minute confirmation that the ship was not only seaworthy but also represented the pinnacle of marine engineering. A Boeing 777 engine remains installed for an average of 30,000 flight hours until it is overhauled. With a thrust of 94,000 pounds, the approximately 8.5-ton engine, GE 90-90B, is one of the world's largest and most powerful engines. The engine change on the OELPD was carried out in 48 hours and 450 man-hours by Austrian Airlines Technik. The GE 90-90B engine is a high-bypass turbofan engine developed by General Electric, GE, for the Boeing 777 aircraft. It's part of the GE 90 family of engines, which are known for their high efficiency and power. Here's an overview of the basic structure and components of the GE 90-90B engine. Fan section. The front section of the engine houses a large fan responsible for the majority of the engine's thrust and contributing to the engine's efficiency and noise reduction. Behind the fan, there are multiple axial and centrifugal compressors. These compressors increase the air pressure before it enters the combustion chamber. The compressed air enters the combustion chamber, where it mixes with fuel and ignites. The resulting high temperature, high pressure gases expand and flow rearward, entering the turbine section. These turbines extract energy from the hot gases, which drives the compressors and fan. This process powers the entire engine and is essential for its operation. The remaining energy from the exhaust gases is expelled through a carefully designed exhaust nozzle, which helps optimize thrust and fuel efficiency. Modern jet engines like the GE 90-90B are equipped with sophisticated electronic control systems. These systems monitor various parameters such as engine temperature, pressure, and thrust in real time, allowing for precise control and optimization of engine performance. This shows how a large motor is rewound, serviced, and tested. The scale, complexity, teamwork, and know-how required by the people at this shows how a large motor is rewound, serviced, and tested. The scale, complexity, teamwork, and know-how required by the people at the KOFFLER electrical facilities in San Leandro, California, is amazing. Everything, from making the wire coils to the vacuum pressure impregnation, VIP, process, is done at this one location. The motor is used to power a pump that removes water from a submarine dry dock facility at Pearl Harbor. The process of rewinding and remanufacturing a large electric motor involves several intricate steps aimed at restoring the motor to its original or improved condition. Rewinding is necessary when the motor's windings are damaged or worn out, and remanufacturing involves a comprehensive overhaul of the entire motor system. The first step involves carefully disassembling the motor. This includes removing the outer casing, rotor, stator, windings, bearings, and other components. Each part is inspected for wear, damage, or other issues. Based on the assessment, a decision is made whether to rewind or replace the windings and whether other components need repair or replacement. Rewinding involves removing the old windings, cleaning the core thoroughly, and rewinding it with new, insulated copper wire of the appropriate gauge. The winding process requires precision to ensure the correct number of turns and proper insulation between the windings. After rewinding and reassembly, the rotor is dynamically balanced. Dynamic balancing ensures that the motor operates without excessive vibration, which can lead to premature wear and damage. After rewinding, the stator and rotor windings are often subjected to a VPI treatment. The motor is placed in a vacuum chamber, and varnish is introduced, filling all air gaps within the windings. This process enhances the insulation properties, protects against moisture, and improves the motor's overall performance and longevity. If bearings are worn out or damaged, they are replaced. Properly functioning bearings are crucial for the motor's smooth operation. The motor is often painted and finished for protective purposes. The outer casing is coated to protect against environmental elements, ensuring the motor's durability over time. Once all components are rewound, repaired, or replaced, the motor is meticulously reassembled. It is then subjected to a series of tests to ensure it meets the required specifications. This includes tests for insulation resistance, winding resistance, high potential tests, and full load tests to assess its performance under operational conditions. The remanufactured motor undergoes rigorous quality control checks to ensure it meets industry standards and client requirements. Detailed documentation of the entire remanufacturing process, including test results, is prepared for reference and future maintenance. Once the remanufactured motor passes all tests and quality checks, it is ready for installation. Experienced technicians carefully install the motor, ensuring proper alignment, lubrication, and electrical connections. The motor is then commissioned, and its performance is monitored to confirm its reliable operation. The process of rewinding and remanufacturing a large motor requires specialized skills, precision, and adherence to industry standards. It is typically performed by experienced technicians and engineers in specialized motor repair facilities, ensuring the motor's optimal performance and longevity. HAEUSLER VRM, Variable Roller Roller, is a specialized machine used in metal forming processes, especially in the production of cylindrical or conical shapes from metal sheets. HAEUSLER is a renowned engineering company that manufactures heavy machinery for metalworking applications, and their VRM machines are renowned for their precision, versatility, and efficiency in the roll bending process. The HAEUSLER VRM machine type is a commonly used 4-roller bed spreader with linear hydraulic rolling motion of the side and bottom rolls. The clip you are watching is an image of a machine bending a giant metal plate with a length of 30 meters and a width of 3 meters, a metal plate thickness of 95 millimeters, and a weight of up to 75 tons into a tube used in heavy industry. Basic characteristics of HAEUSLER VRM, Variable Shaft Roller Machine. VRM machines are primarily used for roll bending, a metal forming technique, and used in the production of pressure vessels, tanks, pipes, and other cylindrical metal structures. One of the special features of the HAEUSLER VRM machine is variable shaft technology. This means the machine can control the position of the rollers, allowing flexible bending of metal sheets into a variety of shapes and diameters. High precision during bending. Computer controls and advanced automation systems ensure that metal sheets are bent to exact specifications, minimizing errors and ensuring consistency in the final product. Their sturdy construction allows them to handle thick and large metal sheets with ease, making them suitable for heavy-duty projects. Automated processes, such as material feeding, bending and unloading, reduce manual labor and increase the overall productivity of metal forming projects. Replacing F-16 wings at the fuel barn at Misawa Military Base. Misawa Air Base is home to Fighter Squadrons 13 and 14, which operate the mighty F-16 Fighting Falcon. Besides supporting combat operations and humanitarian missions around the world, the mission of the 35th Fighter Wing is to protect U.S. interests in the Pacific and support the defense of Japan with a continuous forward presence, deployable force worldwide and focused mission support. Today we take a look at the Misawa Base's fuel barn. Fuel barn is not simply an aviation fuel storage and distribution facility but can also do more complex tasks such as changing or repairing parts of F-16 fighter aircraft. We are watching images of engineers and technicians replacing new wings for the F-16 fighter plane. How can fuel barn of Misawa Air Base replace F-16 fighter plane's wing? Replacing the wing of an F-16 fighter plane is a highly complex and specialized operation that requires dedicated aircraft maintenance facilities, skilled technicians, specialized equipment, and strict adherence to safety and regulatory standards. Misawa Air Base, like other military installations, is equipped with dedicated maintenance hangars, including those for aircraft like the F-16. These hangars are specifically designed to handle major maintenance tasks, ensuring the safety, efficiency, and precision required for such procedures. Fuel barn are equipped with specialized tools, lifting equipment, and fixtures designed for F-16 aircraft. Replacing an aircraft wing involves using heavy-duty cranes, jigs, and precision tools, which are available in here. Skilled technicians, engineers, and quality control personnel with extensive training and experience in aircraft maintenance are available at facilities. These experts ensure that the wing replacement is performed to exacting standards and specifications.